Now let's learn about the orthogonal and orthonormality of the vectors. Okay, so let's say I have two vectors in the dimension of, let's say, 3. So let's say I've got the u vector, which is 1, 2, and 0. I also have this b, which is -4, 2, and 0. Now I want to check if these two vectors are orthogonal or not. Now for that, okay, to check if this orthogonal, okay, I'll have to compute the dot product of these two vectors. So compute this dot product, and if this dot product equals to 0, okay, they are said to be orthogonal. Now for that, okay, let me compute their dot product. So the dot product of these two vectors is the product of their corresponding values. We then sum them all together. So it's going to be 1 times -4, okay. So dot product of my u v is 1 times -4 plus 2 times 2 plus 0 times 0, which is going to be equal to -4 plus 4. Now this is 0, so their dot product is 0, so they are orthogonal in nature. Now for the orthonormal part, okay, to check if the vector is orthonormal, okay, we need to fulfill a couple of qualities. Number one is it has to be orthogonal. So we already fulfilled that quality right here. We checked if it is orthogonal or not. And number two is its norm, okay, which is this L2 norm, okay, is 1. So if its norm is 1 and if it fulfills the quality of orthogonal, then it is said to be orthonormal in nature. Now since it already fulfilled the orthogonal quality, okay, let's see about their norm. So norm of the vector is, at least this L2 norm, is the square root of the summation of the squares, okay, of individual values. So for instance, for this u, we have 1, 2, and 0. So norm of u is going to be square root of 1 square plus 2 square plus 0 square, the individual values. Now this is going to give me the value of 1 plus 4, which is 5. Now 5 is not, okay, this is not equal to the 1. So this is not orthonormal in nature. Now I could just skip for the v, but let's, for the sake of it, let's do it. So for b, the norm of it would be -4, 2, and 0. That would be -4 square plus 2 square plus 0 square. So this is going to be 60 plus 4. So this is going to be 20. Now 20 again is not equal to 1. So this is not orthonormal. Although they are orthogonal in nature, they are not orthonormal. Now for this orthogonal part, we could also plot them on the plane and see if they are perpendicular to each other or not. If they are perpendicular, they are going to be orthogonal. So for this, let's do an experiment. So let me create the two vectors in the dimension, okay, of 2. So let's say I've got u of -2 and 4, and the v is going to be, let's say, 2 and 1. And let me draw this 2D plane, okay, with the y-axis, the x-axis, and then let's draw some coordinates. Okay, so the first u is -2 and 4. It's going to be -2 and 4 is right here. So it's u, which is -2 and 4. And the second one, v, is 2 and 1. That would be 2 on the x-axis and 1 on the y-axis. Okay, so this is my v, which is 2 and 1. Now if I, well, draw the line from the center to this point, again, both of them, okay, I draw it here as well as here, okay, and make sure it is straight. And when you look at this angle between these two, okay, this is the line of B and this is the line of U. Now when you look at this angle between these two vectors, well, it is going to be 90 degree. In other words, they are perpendicular to each other. So if I am to keep on drawing this straight line, okay, so both of these angles, okay, on the either side is supposed to be 90 degree. So this is how we can see if the vector is orthogonal or orthonormal. In case of drawing it in a plane, it checks if it is orthogonal or not, okay. But to check for orthonormal, well, it's got to be orthogonal plus its norm should be equal to 1.